Yeah. Alright, here we go. So, a couple of vocab words. First of all, a class. Yeah? A class refers to a group of numbers within a given set of data. Since all our data consists of integers, each class will have a lowest integer and a highest integer. These are called your class limits. Nice try, nice try. No, it's an integer. Integers are class limits, so no decimal places are class limits, right? When you group the data in the appropriate classes and you tally each class, this is called a grouped frequency distribution. Yeah, a grouped frequency distribution. Okay, so basically you take a bunch of numbers and you group in the classes, kind of like how the school takes 2,100 kids and groups them into little classes, right? Smaller classes. So, here's the technique. Ready? Alright, basically, to group them into 6 classes, you take the highest number minus the lowest number and divide it by the number of classes that you want. So this example says group it into 6 classes, right? Usually in the example it tells you what the highest number and lowest number is. If it doesn't, then you gotta find it. So in our case, the highest number is 86 minus 58. Divide that by 6, and you get it's like 4.6 repeating, right? Always, always, always round up, right? Which means there will be 5 numbers in each class. 4.6 repeating, right? 4.6, right? So always, always, always round up. So that way every class will contain, the other way it'll cover all the numbers in the classes, right? So basically you start out at 58 and you want 5 numbers in that class. So, I mean, we have 5 fingers. You could do it this way: 58, 59, 60, 61, 62. So this class is going to contain numbers 58 to 62. Another way you can do it, right, is you can go 50, you start with the lowest number, which is 58, plus you want 5 numbers, right? What is that? 63, right? That's 63. But since you started with 58, take away 1, and that's 62. So that'll add the right numbers, because 58 is counted in the number class, right? So if you go 58 plus 5, you gotta take away 1 because you already counted the 58. Is all. Or you could just do your fingers. Whichever. Whichever. So the next class starts at 63. 63 plus 5, take away 1. 67, right? And then the next class will start at 68 to 72, and then 73 to 77. There is a pattern. 78 to, yup, and then 83 to 87. Now, here's what I made you do your stem and leaf plot, which, by the way, if you're just joining us on the internet, we did a stem and leaf plot to organize all this data. Here we go. Just count. How many numbers are from 58 to 62? 6. Nice. How many numbers from 63 to 67? Nine? Is that a... It's 9. Yeah, you should have 9. Alright. What else? 11. See, wasn't that faster? Otherwise, you would have to count all those numbers from the list of unorganized numbers. Right? So, it's definitely plot, or just write them in order, whatever. So, list the numbers in order so it's easier to count. Yeah? Yeah? Don't believe me? Whatever. Whatever. Alright, let's do it again. Let's do it again. Let's try a different size class this time. Okay? This time, oh, by the way, change that top number from 95 to 97. Hello. Yeah, my bad. My bad. 5. It's 7 classes. Biggest number, 265. Where is it? 254 is the highest number? Gosh darn it. 254. All right. So, delete. Sorry. Okay. Sure? Gosh darn it. All right. So 254 minus 97 divided by 7 is about, what is it? 22.4, right? Oh, and this thing just got stuck. That's okay. It's gonna work out. It's gonna work out, and there it is. Okay. Yep. All right. It's 22.4, which means you round up to 23. So you want 23 numbers in each class. Yay? So to find the first one, you start at 97, and then you go 97 plus 23, take away 1 is 119. Yeah. 119. Right? And then you start at 120. Where is it? 142, because you, well, 120, yeah, 142. Good. And then 143 to 165 and 166 to 188, 189 to 211, okay, 212, 234, 235 to, where is it? 257. Notice that I wrote that green. This last number has to be either greater than or equal to your highest number, so that way it will count. Okay? Just like you're counting. That's why I made you put it in order. So you, oh, where these numbers are coming from? Okay. So you start from the lowest number right here, and you need to have 23. It's like 23 numbers in each class. So to get that, you add 23 and take away 1 because you already counted the first number. Okay? Sure. Basically, you're dividing it into little classes, right? That's it. Like you're taking a bunch of kids and splitting up into small classes. Yeah? All right. Are we counting? How many from 97 to 119? There are 5. That's right. And then 8. You count. That's why I made you do the 7-leaf plot. So count the numbers from 92 to 119, and then just how many are there? Yeah. Did we get 145? Sorry, 143 to 165? 6. Okay. And 2. Okay. 9. 6 and 74. P.S. If you add all of this up, if you were to add all of this up, what should it add up to? Yeah. So it should add up to 40. That's how you double check yourself. Yay? Yay. Okay. Yeah? Alright. Here we go. Couple of going backwards questions for you, and then we'll do one boundaries, and then we're good. Ready? Okay. Here we go. Suppose 38 to 55 represents the first class in a group distribution. How would the second and third class be like? So, to figure this out, we need to figure out how many numbers in a class. Right? So how many numbers are between 38 and 55? Well, you just take the upper minus the lower, then plus 1. Because then you have to add that 1 back in again. So if you go 55 minus 38 plus 1 is equal to 18. And sure enough, you can count that because you go 38, 39, 39, that's 18 numbers in a class. Yeah? So the second class right? It starts at 56, and then you start at 56, and then you would add 18, and then minus 1, 73. So your first class goes from 56 to 73, right? And then for your third class, since the last one was 73, we start at 74, and add 18 minus 1, 91. So the last class, the third class would be from 74 to 91. Okay? It's all good. Alright, here's another one. These are all multiple choice test questions, by the way, so you got to know how to get to them. Example 3, suppose the lowest and highest number of a data set are 80 and 200. There's a total of 9 classes. What is the lower limit of the second class? Ooh. What do we need to know? Oh, it's finally working. Awesome! We have bells. We have bells. Oh, goodness. I don't know. Yeah, okay. Yeah, I'll go back. Sure. Yeah. Oh, cool. Alright, so, here we go. So in example 3, the lowest, highest numbers are given. There's 9 classes in this frequency distribution. So what would the lower limit of the second class be? What would you do first? Yeah, number in a class. That's right. So to find the number in class, just go 200 minus divided by 9. Yes. Which is, yeah, 13.3 repeating, which would mean there are 14. Right? So there's 14 numbers in the class. Okay. The first class right? The first class will start at 80, and then plus 14 minus 1 equals 93, right? So the first class will go from 80 to 93, okay? So that's easy. The lower limit of the second class, yeah, would have to start at 94. Oh, not 94, 94. There you go. So, whatever, right? Because the only thing that we need is the 94, just the lower limit. Joy? Joy. You always round up. You just always round up. Even if it was 13.01. Yes, because you want to cover more, a little bit more, to make sure everything gets included. Yes. Yeah. Kind of like can't really have 3.2 kids. Okay. Alright. Okay, here we go. The difference between a limit, right? The difference between a limit and a boundary. Okay? Yes, very good. Remember for boundaries, last time you add or subtract 0.5. Since limits are integers, for boundaries you have to add or subtract 0.5. So from the lower boundary, you subtract, lower limit, you subtract 0.5, and from the upper limit, you add 0.5. Right? So, this is from the first example. Instead of 58, 58 minus 0.5 would be 57.5 to 62.5. If you just add 0.5 to the higher one and subtract the lower one. And so check out what happens. This used to be 63. This becomes 62.5. Notice that it copies. Yeah, it'll connect. If you add 0.5 to 67.5, you'll have 67.5. Alright? Take away from 0.5 from 68, you get. Okay? So 67.5 to 72.5. And 72.5 to 77.5. And 77.5 to 82.5. And then 82.5 to 87. Right? All that does is it takes those individual integers now it connects together, which brings us to what a histogram is. Yes. Yes. Alright. Yeah. Alright, I'm going to skip over example 4 real quick. Just go over the histogram. Right? The graph of a group history distribution is called a histogram. Right? In a histogram, you use the boundaries. Use the boundaries to graph it, so that way everything is connected. So, it's kind of like a Pareto chart, but this time we don't care if it's ascending or descending order. It just is what it is. Okay? So using that previous example, I just copied it over to here. It is a bar graph, basically, yes, but it uses boundaries, not the limits. Okay? So in order to graph a histogram, you have to find the limits, then the frequency, then the boundaries. So you can graph just the boundaries and the frequency. Okay? Alright? So, to graph this thing, you just start at some point. So, like, over here would be like 57.5 to 62.5. And 62.5 to 67.5, 67 to 72, and 77. And extend this a little bit. And 82. And finally 87. Okay? Alright, highest is 11. I think I gave you 10. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11 would be right up there. Okay? So a histogram, again, it's all connected bars. There's no gaps in the histogram because it goes by the boundaries instead. So here we go. For the first frequency, it goes to 6. So from here to here is 6. Yeah? Sure. And 9. Then 11. Just go past 10 a little bit. That. And 6. Joy. And 3. that, be a histogram. Woo! Joy, right? Joy. Okay, here we go. Oh, you're not done. It's all good. Alright. Your turn. If you wanted to practice using that histogram, that's fine. We're not going to do it together. I do want to go over example 4 because that's like a multiple choice question on a test. And after that, we'll be done. Okay? Josh, good? Okay. Here we go. So 4 is kind of the same thing as the limits one, but this one is a boundary. It's as for the upper boundary of the 6th class. So you have to add a subtract 0.5 to it. Right? So the 5th class is 94 to 101. What else do you know? Or what else can you find out? The boundaries? Okay. Yeah. So how would you do that? Add 8? Because there's 8 numbers, aren't there? Yeah, because if you count from 94 to 91, there are 8 numbers. Here, really quick, here's how you do it, just in case you didn't know. Number of data. If you go 101 minus 94 plus 1, that would be 8. Okay? So the 6th class would start at 101, 102, there you go, 102 plus 8 minus 1, that ends you up at, what is it? Oh, 9. So this would be the upper limit, right? That's the upper limit of the 6th class, so what would the upper boundary be? Yeah. It's 109 plus 0.5, which is 109.5. Okay. So what's the difference between a boundary and a limit? 0.5. Which one has the 0.5s? The boundaries, right? Yeah. And then when you're graphing histograms, do we graph boundaries or limits? Boundaries. Alright. There you go. Alright. I think you got like maybe 3 or 4 of these to do. Make sure you read it and know if you're doing limits or boundaries for your charts. Oh, good. There we go. And then we'll go over it tomorrow just before your test, which again should be about maybe 30 minutes, not even. And then we shall have Christmas party. Yay. Did you already have one? Alright, you're awesome. Okay. Eh?